water and fertilization. As a grower, you are always working towards achieving the best quality of your crop. To make this possible, Eurofins Agro provides you all essential information related to water, fertilization, growing media, and plant health. In this presentation, Jan Hardeman explains testing of water and its relation to fertilization of hydroponics and pot plants.
Hello, my name is Jan Hardeman. In this presentation, I'd like to tell you more about fertilization for hydroponic systems and potted plants. This is video 2 within our series Horti Expert Sessions 2021. First step I like to discuss is the quality of the water source. You will see an overview of a greenhouse, and there are several water sources you can use depending on availability at your crop. The first one, rainwater, which is often very clean, surface water, borehole water or tap water. And the first step for calculating an optimal fertilizer advice is taking care of the result of the water source analysis, which is very important. So that's why we start with this step, the quality of the water source. We advise to check this 1 to 4 times a year. This depends on the fluctuation of water quality because of seasonal effects. And also borehole water can change during the season. This depends also on the region where you are. So it's very important to check this regularly. The parameters we analyze are pH, EC, macro and micro elements, and total and temporary hardness. Additional, we can analyze also iron total, which is very important for borehole water. Iron total levels, if they are too high, they can cause clogging of fertigation systems and drippers. So based on the iron total analysis result, you can decide or you need deferrization or not. The turnaround time of this analysis is 1 day. The next important parameters within the water source analysis is the bicarbonate. High levels of bicarbonate can cause too high pH levels in your system. And this will cause nutrient deficiencies, like manganese deficiencies. So it's very important to use in this case acid, like nitric acid or phosphoric acid, to neutralize the bicarbonate. By adding this acid, the pH will drop according to this chemical reaction. Please keep in mind that this chemical reaction takes time. The carbon dioxide gas must escape. So it's very important also to use not fully closed systems, because in that case the carbon dioxide cannot escape and the chemical reaction is not completed. So use open systems so carbon dioxide can escape. If you go back to the overview of the greenhouse, we will focus now on 2 different analyses. For the hydroponic system, fertilizers recipes are calculated based on the drain or slab water analysis. And potted plants, based on the growing media analysis, we calculate optimal fertilizer recipes. Within the hydroponic system, there are several growing media, like inert growing media, like mineral wool or perlite, or organic growing media, like peat and cocoa peat. Or for floating techniques, water is used. For potted plants, often organic growing media are used. In hydroponic system, we analyze the drain or the slab water within the drain water check. It will give insight in plant available nutrients, and we advise to do it every week, which is very optimal, or every 2 weeks, which is the most common. The parameters are pH, EC, macro, micro elements, and additional we can analyze aluminium or urea, like urea which is used in Phalaenopsis cultivation systems. The method is direct analysis after filtration, and the turnaround time is 1 day. For potted plants, we analyze the growing media, the potting soil check. It will give also insight in plant available nutrients. We advise to do this every 2 weeks, depending on the type of crop. Also, the turnaround time is the same like water, 1 day. The parameters are pH, EC, macro and micro elements, and also we can analyze additional aluminium and urea. The method is 1 to 1.5 volume extraction with demineralized water. So we take 1 part of soil, 1.5 part of demineralized water. We shake it, make an extract, and analyze the extract. If you go to the report on page 1 of the Drain Water and Potting Soil Check report, there are several columns. In the first column, you will find the analysis results. In the second column, we calculate this analysis results to a standard EC, so we can compare it very easy with the target for the specific crop. We make also a sodium and chloride correction in it, because it are not nutrients for the crop. In some cases, chloride is used as a nutrient for the crop, like in tomato crops, and then the conversion, the correction is different. In the fourth column, you see the valuation, so the difference between the target and the analysis result. In the fifth column, you will find a standard nutrient solution for the specific crop, or the basic scheme. And based on the analysis results and the crop stage, we make corrections on these standard nutrient solutions. These corrections you will find in column 6. In column 7, you see other corrections on the basic scheme. It are corrections for the water source water and the recirculation analysis results. I will discuss in the next slide. In column 8, you will find the nutrients which are dosed via the A and B tank. And the total dose, so the recirculation and water source water and the A and B tank amounts, are given in column 8. It will give the total dose which will go to your crop, in this case with the drip EC of 3.0. In column 7, we present the recirculation percentage and the water source analysis together. So in this case, you see 0.8 EC. This will mean 20% of the EC of the drain water analysis. In this case, 4.1. So the recirculation percentage in this case is 20%. If we calculate the fertilizer recipe, we use some information from the grower, and based on the analysis results, we can calculate an optimal recipe. In this case, the crop is tomato. The grower is using mineral wool as a growing media. The growing stage is 7 trusses. Drip EC is 3.0. Recirculation percentage is 20%. So in this case, the analysis results is 4.1. 20% of this is 0.8. Fertilizer system, an A and B tank, tank capacity 1000 liters. The fertilizer package, it has solid fertilizers, and they are using chloride as a fertilizer. In this case, potassium chloride. The water source water is borehole water. So with all this information and the analysis results, we calculate the A and B tank recipe. It is a complete fertilizer recipe. In this case, 1000 liter tanks, 100 times concentrated. This will mean 100,000 liter fertigation water. So a stock solution for this amount of fertigation water. And below the A and B tank, you will find the crop stage, the drip EC, and also the drain sample, 20% recirculation, and 80% of the water source water is used, with also some nutrients in it. In this case, there is some bicarbonate in the water source water and some calcium. So there is some bicarbonate in the water source water. That's why we calculated some nitric acid in the B tank. So the conclusion, first step is to analyze the water source with the water source check. The purpose of this is check the quality of the source water, salinity, nutrients, pH and bicarbonate. The second step is the drain water check or potting soil check. The purpose of this, optimal nutrient availability around the roots to avoid nutrient excess or deficiency. And these two analyses together, 1 and 2, will create optimal fertilizer recipes. And for optimal control, we can analyze also the fertigation water, which will go to your crop. We calculated an A and a B tank. The fertigation water is dosed to the crop, but do I really give what I expect to give? You can check it with a drip water check. For more information, please visit our websites for more information about analysis and insights, and also more information about sending your samples. Thanks for listening. For further questions, do not hesitate to contact us. I hope we can help you with calculating an optimal recipe for you. Thanks.